Hello, this is Tom Klepper and welcome to the final Part E video where we are going to add the SMA connectors to our bias T and then wrap it up with generating Gerber files to get a printed circuit board made. In the last video I had talked about trying to optimize our circuit within HFSS 3D layout. And the reason is because our minimum here was a little bit off of 3 gigahertz. Well, I can tell you that I tried that. It was not successful. So at this point in time, we're just going to stick with the design that was optimized in Nexus. All right, so to add the connectors, you're going to need a couple of things. First off, you're going to need to download this file right here and just drop it in the same directory as your bias T project. Then we're going to need to go back to our ports. Let me just rotate this so we can kind of take a look at them again. So we're going to remove these ports because we're going to add connectors to them. So go ahead and delete the ports. So now we're back to our printed circuit board. And we need to add the ground pads on either side that we're going to solder the connector to. And if you had uploaded the personal lib contents to your personal library, so that means if you go to now my personal lib is right here, you should have these guys right here, this MW class, and then you may have thrown this ground pads bitmap into the proper directory. If you had done that and we say view component libraries, you should be able to go to your personal library here, personal library, and you see this thing, and you see this ground pads. So I've already gone through the trouble, which was a real pain in the butt, of creating these ground pads, and you'll see how easy it is to add. So you just double click it like a regular component, and let me just verify our layout settings and snaps are right. So we have display, 100 mil, 50 mil, snapping, vertex, edge center. Okay. All right, so double click on ground pads, and it should come over here, and it's going to it's going to want to snap right to the edge of the end of the line. So we're looking for the triangle. Where is it? Oh, I almost had it. Okay, so it snapped right to the edge there, and now you know why I have this that W connector offset. So this edge of the connector pad comes right to the edge of the board. So we're going to do the same thing over here. Double click on it, and since it's a component, I can hit that R twice to rotate it. We're going to look for it, and bam, that's it. And let's go ahead and add one down here too, in case you'd want to add one for the bias port, in case you want to put like an SMA connector there to add for the DC voltage bias. All right, so now Control D is in delta. There we go. Okay, now we have to add our connector. So here's what we do. This is the best way that they were suggested to do it. So we're going to do the same way. So you're going to go File, Open, making sure you're going to go to this this archived thing and say Open it, and just say OK for this. It's going to unpack it and open it up as a complete separate project. And say Close, and there's the connector. So what it did is open up as a separate project. Now I've gone through and already generated this from basically from scratch, from dimensions and the data sheets. And we're not going to discuss too much about doing three-dimensional HFSS modeling in this class. So what I want you to do though is go over here, and this 142, this guy right here, you're going to click on it, right click and say copy, go over to your bias T and right click and say paste. And what that's doing is pasting it into your project, since this is a separate project. So now you can go back and close this one you had just opened. So this is the easiest way to incorporate this connector into your project. And so now we have this connector in our project. So we have these lengths for the ground tabs, and we have this little feature here, something I added to kind of simulate solder to go down to the center conductor. All right, So again, I'm not going to talk too much about that. So let's go ahead and close all of our windows. And all right, let's go back to our 3D layout guy. Double click on that. All right, so now we're going to add the connectors to it. The way you do this is you just click on this and say copy, Control C, come down to your layout and go Control V or paste and just say OK. And it should, well, it's going to paste it to the 0, 0, ironically, which is where we want the first one. You want it right there at 0, 0. So we're going to do the same thing again. Control C. We hit Control V for paste. Let me zoom out a bit here. And we're going to need to rotate it. Come on. It's not where I want it. Okay. Here we're going to hit Control R to rotate it around. And we're going to drop, oh my God. We're going to drop it on the edge of the board. See, it's too far over. Should go right there. Now we can check the footprint to make sure that it did, yep, so put it at 1 inch and 0. No, come on. Okay, there we go. So you should see the little dielectric gap right between there. All right, Control D. And if you rotate it, you'll see the connector attached to your board, which is kind of neat. You also see the ground vias that are there. They all came with the component placement. And now we are ready to add the ports. So what we're going to do is now we have to add the ports. They're going to show up at the end of the SMA connectors. So what we do is we click on each connector, right click, and you're going to go down here to ports, and you're going to say create ports on component. Now this only works if you've already created the component such that it will accept a port on it, and I've already done that. You're going to click on no net and say OK, and now we have 2 ports on the edges of the connectors, so we're all set, ready to go. We can look at the HFSS extents to see where is the air box now. All right, so the air box is there. It's a little big. If you wanted to, you could probably change this if you wanted to 1, or the positive padding, change that to a 1 if you like, but I'm just going to leave it the way it is for now. That just gives you an idea of what the actual simulation space is. And now we should be able to go ahead and run the simulation. So let me just take a look at the sweep. I think I still have it. I put it at 10 megahertz to 4 gigahertz. So we're going to do a full sweep. And I'm going to pause the video while I do that. So again, you just click on Setup, and you would say Analyze. And it should go ahead and do the full 3D analysis, and I will pause the video. Okay, the simulation is done, and so let's go ahead and take a look at the output. Now, these are from the old S parameters, so we're just going to delete this plot and create a new one. So create standard report. So you have the new definitions, so the new ports are there. So S11 and S21. And of course, it didn't change much because the connectors are well matched, but it just gives you an idea that you can actually do a full 3D simulation, including the connectors in your project. So this is the final, this is what you should see when you solder the connectors on and do your simulation. And again, the actual board would look like this when you solder your connectors on, and eventually you would attach probably another connector or just a pair of wires to your power supply to add the biasing to it. So ultimately what we have here is we have a transmission line that goes from one connector to the other, and we have this little circuit here where we can apply a DC voltage to this line without influencing the RF path insertion loss of this line. Now, it kind of goes without saying that normally you would have a DC blocking capacitor on one side or the other. We don't in this project. You can actually buy for about 20 bucks a nice SMA pin to socket DC blocking capacitor packaged up if you wanted to go ahead and use this in an actual circuit. Okay, so that's the connectorization part of it. So now what we're going to do is we're going to create the Gerber files. And if we did everything correctly, it should go pretty straightforward. So let's do this. I'm going to say View Layers, and in the top layer I'm going to turn off the components by doing that. Oops, sorry. Nope. There it is, that last one. And then what you're going to do is go to File and Export, and just first we're going to export the drill file, which is all of the vias, and so that's the NC drill, and we're going to put that in our directory. And I'm going to delete all this other stuff and just the NCD file. You just leave the defaults as they are, say OK, and when we go to our directory, we should see this this file. So here's what we got to do. So we need to change the names of them so Oshpark can bring them in directly. So all drill files you're going to change to any name and .xln, X-ray, there we go. So now that's our drill file, and we're going to go back here and say File, Export, Gerbers. Same kind of deal. Get rid of the rest of the stuff and just say bias T Gerber. Now when you do this, a little window is going to come up, and here's what I'd recommend doing. Just go ahead and delete all of these, and we're going to start fresh. So what we're going to do is we want to export. So one, let's make this the top silkscreen layer, silkscreen top, and then two will be the top solder mask. Then the 3 will be the actual top layer. 4 will be the bottom layer. 5 will be the bottom mask. And then 6 will be the outline. Okay, so kind of going from top to bottom, it'll be silkscreen top, solder mask top, the top layer, and then the bottom layer, bottom mask, and then finally the outline. Just say OK. And then we go over to our project, and again we have to rename them. So the top silkscreen renamed to GTO. The next one, which should be the solder mask, the top solder mask would be GTS. The next one should be the top Gerber file, so the .GTL for top layer. The fourth one should be that Gerber bottom layer, GBL. The fifth one should be the bottom solder mask, so .GB solder mask. And then the final, the sixth one will be the outline. So it's .GKO for outline. All right. So now we have all of our files. There are 7 of them. And all you got to do is just take all of these guys, highlight them, right click, and then zip them up using any zip. So I'm going to use 7-zip and say add them to biast.zip file. And there we created our zip file. And now we can go to the OshPark website, say browse for files, UD biast zip, say open, and it'll open up and process them. And if we did it all correctly, including that non-closed outline, it should recognize everything. So what do we have? Okay, so it shows you this kind of like this olive green is going to be the FR4 board, which it kind of is. These are going to be the gold traces. So it looks like everything is exactly what we like for the top layer. And of course the bottom layer is solid.